Hi, my name is Balázs Ligeti, and today I'm going to talk about visualizing complex datasets using heat maps. So, in this short session, we are going to create a heat map using a web tool. So, first, we are going to familiarize with the data. Then we are going to upload our data to a web tool and through a heat map. And finally, we are going to interpret, fine-tune, and evaluate the results we can obtain. Okay. Heat maps are useful for visualizing low to middle-sized data. There are advantages, but they can show the internal structure of the data as it is. Here we are going to use microbiome data as examples. So let's say we have stool samples. Each column represents a biome, and the numbers are the proportion of the taxa in that given sample. A value 0.5 means that the given taxa has a 50% contribution to the community. In this example, after filtering, we kept 100 taxa, and we have 3 different predefined groups. So let's download the file named heatmap example Excel file from the course site. Then open a web browser and open the following URL. And after that, using the heat map, we are trying to find out how many taxa and sample groups can we obtain. And we are looking into some fine-tuning options, such as choosing a metric. Okay, optionally, you can try out another tool for heat maps. So first, let's familiarize with the data itself. So this is the raw data. We can see that this is a really large table. It contains a few 10 columns. Each columns represent a sample. So this is a microbiome of a person. In the first row, we have a unique ID for the individual taxa, and in this column, we can see that which taxa we are looking at. Okay, so in the first row, there is a label for each column, because let's say in this example, we have some additional information about the patient. Okay, so next, open the web browser and the given URL. So this is what we can see at first. So first, choose upload file and select the heat map example XLSX. Okay, let's open. Okay, so first we can see the initial heat map. The very first step is let's just fine-tune this picture. So first you can see that only the rows are clustered together, not the columns. The columns represent the samples. So we would like to clustering the samples because we want to know that what kind of sample groups we can obtain. So here in this section, we just extend the clustering to the columns as well. And we are saying that please show us the hierarchical clustering. So we have some reorganized heat maps. In the heat map, we can see that it only fulfilled the part of our screen. So next, just click here, show advanced option, and add some width to make this picture more readable. Okay, so let's extend the columns as well. Just a little bit more. Okay. Okay, so here is our heat map. What is a heat map? So each section or each value is color coded. So in that case, blue cell means a low value, yellow means a large value. So if we can, we can change. We have various options. So traditionally, or many times, we can see some other coloring schemes, like one from red to green. Okay, here red means a low value, green means a high value. Okay, let's go back to or we can try other one, and we are choose that looks for us. Okay, so here just choose the blue yellow because it gives us more contrast at first. So we can play with the coloring as well. So like adding more colors or more, let's say, contrast. Okay, so this is one option that we can play with. So defining the colors. The other important thing about the heat maps is the applied distance measurement method. So because what the tricks for the heat maps, we reorganize this table, the original data table, what we saw in Excel, in a way that the similar columns, so the similar microbiomes should be next to each other, and also the same goes for the rows. So similar, so those sample series that have the same composition tends to be under. Okay, so that's what the clustering does. The goal of the clustering is the reorganization of the columns and the rows. So similar rows and similar columns should be next to each other, and it helps us to immediately see patterns in the data like we have. So for example, we can obtain a cluster here, so which means that in this section, in these samples, in this group of samples, we can see that these taxa are expressed or have a high contribution compared to other. In this bluish area, what we can see that these taxa, like taxa 2, 8, and 5, is just missing from this group. Okay, so what can help us in the reorganization? So we mentioned the applied distance measurement method. We have normally many kind of other metrics. Let's try the Kendall's tau or the sperma rank correlation. Okay, so basically they give, this is almost the same as the previous picture. So we can see well organized groups in these examples. In this example, so what we can see that we have basically three different groups of samples. So here, for example, that these samples are grouped together. These samples as well, and this is another cluster. Okay, so we have discussed how we can combine the columns. We have various methodologies for it, so like the complete linkage, average linkage, and so on. So, but in this case, they give the very same results. Okay, so let's move on. How can we choose appropriate metric or clustering approach? So basically, what I prefer is depends. What I would like to say, it depends on the actual application. So choose whatever is suitable for your application. Okay. So also we can dig in to gain some insight of this cluster. So selecting this, we can move in and we can see that, okay, which taxa are highly expressed in this section. So we can see that in these samples, these are the taxa that are looks very similar in the application. So here is a subgroup, but overall it can be seen as this group. So also we have an option to investigate the dendrograms, so the hierarchical organization of the taxa and also the columns. So for example, in the microbiome application, taxa that are part of the same genus tends to behave similarly. So they might be evolutionary related species. Okay, let's look into a group of the samples. So here we can see some nice clustering. So the first group is this. The second group consists of these samples, and the third group is this. So what we can obtain from the original plot, that we can, based on the data, we could well recover our original groupings. Okay, let's summarize what we have learned today. So we looked how to build heat maps using a web tool. We started to using and interpreting dendrograms, and we know what should be looking at, and we looked into some option how we can optimize a heat map or gain some insight into the data. Okay, thank you very much. Bye.